Yeah, but
Appendix D.
but I thought.
Yeah, we haven't talked about it yet, so.
Yeah, I was gonna say because just the way you have it set up, you have the dates over here that tell you the time frames. So like, there's 2 dates. Does that mean?
Those are the days that I'm
first
talking
one will
about.
go to the first, and the
That's
second
just
one
the days we're going to be lecturing over this. So today,
tomorrow we will be having quiz on homework, basically.
yeah, on the first homework assignment, the cumulative review of 1 through 6.
And then would both these homework assignments be due that day, or just?
So we're going to go over today. We're going to just about to get into Appendix D.
Okay.
So the rule of thumb to be sure that you're on track is if you're able to turn in Appendix D by Thursday,
Right.
you're on track.
Cool.
If you're almost done with it come Thursday, you're pretty much on track. If you haven't started it by Thursday, then you're probably somebody who's got time with the weekend, so you'll do fine. You'll get it done.
Cool.
Okay. So a few of you guys have seen this synthetic division stuff before. So I have this big, just on the back of that factoring practice worksheet, this here. So here's an example long division. Let me try to show you with this, because this is kind of nice. Here's a problem we did earlier that's really disgusting. And I want to point out why we wanted to make a new way to do this. I've got a lot of shit written up here that's really unnecessary, right? It's not necessary. These are totally not necessary because what's going to happen every single time with these, they are going to cancel. But this process requires me to write them so I can see them cancel. Do you guys follow what I'm saying? So we decided there's got to be a better way. And what do we do every single time that's so easy to forget? We have to change the signs. Right? You guys understand? So this piece is what's not necessary. Where'd that 8 come from? It came from 8 times the opposite of -2. Are you guys semi with me what I'm saying here? So we did 8 times -2 and then we changed the sign. I mean, 4 times -2 we changed the sign. Are you guys with me? A little bit.
I don't understand
So,
why we're changing sign.
because we do. Here. 9 times 70. I love it when I'm allowed to say that because that's just the way it works. 9 times 71 is 639, and then don't you subtract it to see what's left? So isn't 9 times 71 positive 639?
Yeah.
And then what do we always do? We change the sign. Yeah. So whatever I get, when I multiply this by this, I have to subtract it. And how do I subtract it? I distribute a negative. Everything changes. All the signs change.
So you're trying to get the remainder.
I'm trying to see what's left.
Yeah.
Exactly. Let me stop there. Please, I'm hoping everybody can see. A lot of people don't believe me when I say this. But everything we do with variable expressions is exactly the same thing we do with numbers. I know you don't believe me, but it's got to be true. Because what are variables? Freaking numbers. There's numbers I don't know yet. So are they going to look worse? Oh, hell yes. Because we're working with things I don't know, or we're working with an infinite number of things. I mean, so of course it's going to look kind of gross. But the processes we use are the same. Finding LCDs. We're going to get into that in Chapter 7. You might have talked about it a little bit in Math 90 when you have expressions that look like this. Oh, shit. Right? So that kind of thing. Okay, maybe. So how would I do it? I would just say, well, this guy needs an x minus 4. I multiply him by x minus 4 on the top and bottom. This guy needs an x plus 1. It's exactly the same process, believe it or not. Okay, so here's synthetic division. This is the appendix, so it's way in the back of the book, if you're looking for it. Appendix D. My math lab, I actually did assign problems from it on my math lab. By the way, before I forget, if you're doing my math lab, you must do every single problem, because I've already picked the ones that match what I've assigned the closest. Don't do every third out of every third I've picked. You're like, wow, it's quick. Do everyone. Okay. So here's the idea. The only things that really matter up here are the numbers. The 4, the 8, the 18. Those are the only things that really matter. And this shit doesn't matter at all. Plus, I want to build into this process that I'm going to create. I want to change the sign once. So I'm not changing the sign every damn time because I might forget. All right, so let's stay with me now. Here we go. You guys are like, what is happening? So I want to create a process that will make this easier. In fact, what we're going to talk about right now will work anytime I'm dividing by x plus or minus something. This process will work. So the first problem we did today was x squared plus 1 at the bottom. This process would not work with that. So it's a little bit of a trade-off. It's easy, but it only works sometimes. So here's the first thing we do. Now the organization of it takes a little bit getting used to. I don't watch hockey a lot, but I call this the penalty box. I don't know if you guys watch hockey. Little penalty box. Stay with me now. So instead of, so see, this x doesn't matter worth shit. Because what really matters, where'd that 8 come from? It came from this interacting with all these numbers down here. This is what really matters. So that's why it's always going to work if there's an x, because then I'm just going to focus on this. So did I put 4 times negative 2 here? No, it ended up being plus 8, didn't it? Because I had to change the sign. So instead of negative 2, I'm just going to change the sign to 2 to begin with. So I only have to do it once. Does that semi-make sense? The easiest thing to forget in this whole thing is to change these damn signs. And then the whole thing goes to shit if you do that once, right? So I'm going to put a positive 2 here. I'm going to change it from the negative 2 it was. Now, as long as everything is in order, I can just put the numbers here. So anything that's missing, I have to put a 0 in like I have had to before. So what do I have here? I got 4 and, of course, 0. So I'm just going to write the coefficients. I really want this to make sense. So all that matters here are the numbers. These are like terms. So why do I have to write the stupid x4s? These are like terms. Why do I have to write the freaking x cubes? That doesn't matter. Okay, it matters at the very end, but in the work it doesn't. So let me just write the coefficients. So 4, 0, right? There's no x4s. I'm looking right here. 4, 0. Keep going for me. 2, 0, negative 7, 5. Okay, so this is kind of nifty. Okay, we're going to do something else this semester known as matrices, which is sort of similar, just focuses on the numbers because that's all that really matters at the moment when you're working something out. Okay, so yes, you got to be careful. You got to put zeros in there if something's missing. All right, now watch. See how the first answer is always going to be this. Because I just said it only works if that's 1x. So why did we put 4x4? Why did we put a 4 here? Because 1 times 4 is 4. Right? So this is kind of nice. So whatever this number is, it's going to be part of the answer. This row here is going to be the answer. This row here is going to be the answer. It's going to be the coefficients of the answer. Now, just stay with me. Wait till you start to see things happen. Now, what did we do with this? What did we do with this 4? Then we multiply it by negative 2, back when we were kind of like naive and didn't really realize how much power we had. So now we're going to do better than that. We're going to multiply it by positive 2, so I don't have to change the stupid sign all the time. So 2 times 4 is 8. And see how we did 8 plus 0? So you multiply by 2, add. Multiply by 2. Do you see where we're at? So see this 0, 8, 8? Isn't that right here? 0, 8, 8. Do you see that? It's only focusing on the numbers and the numbers that actually matter. It's really nice. 2 times 8, 16. 2 plus 16, 18. 2 plus 16, 18. Right? 2 times 18, 36. 0 plus 36, 36. 2 times 36, 72. 72 minus 7, 65. 2 times 65, 130. 130 plus 5. 135. Holy shit. Now, watch how this works now. You guys all see that, right? I don't have to do this again, do I? Bam, bam. You can see it. It only picks out the most important parts. This accomplished everything that did. And that is nice. I can actually maybe even do some of this stuff in my head. Because there's less shit to kind of keep in my head. Or not, which is fine. At least it takes up less space on the paper. Right? What was this in front of to begin with? That was the problem. What was it in front of? x to the fifth. And dividing by basically x.
you're taking
So it's always going to be
x to the fourth.
one less degree. So this is the coefficient of x to the fourth, and keep going. 8x cubed plus 18x squared plus 36x plus 65. And then this last dude is the remainder. So it's going to be the one like we did before. Put it over what we divided by. Plus 135 over x minus 2. So this was disgusting as all shit. This is much better, accomplishes the exact same thing, but the fact that it's so nice is because it only works in very specific situations. When the bottom is x minus something or x plus something. So if this was 2x minus 3, it won't exactly work. I can kind of force it to work, but it won't be as pretty. And definitely if this was x to the third plus 7, it ain't going to work worth shit. Right? It's got to be linear. Okay, maybe. Yes, sir.
Can you explain again why you're dropping an x?
Oh, so do you see how basically, I know this is x minus 2, but isn't this dividing by basically x?
Yeah.
So when I divide x5 by x, I get x4.
Yeah.
Good. That's it. Good. I like it. Let's do another one.
It's
Yes.
always a one in the coefficient, right? Like that's the only way you can synthetic division.
Oh, yeah.
Yeah,
But there's a
minus
1.
2, so like
Exactly.
it was 2x minus
There's
2,
a
it
1
doesn't
there.
work.
That really is one of the things that makes this so stupid easy.
Because that's how you can get it to cancel out with the first term.
Yeah, and that's why this just drops straight down.
Drop.
Exactly.
Okay.
And that gets us started. Let's do another one. And then another one. Oh my God. Alright, so what if I had I like it.
So you start with the -3.
Yeah, so what goes in the little... let me let you guys write that down first. That would probably be... Yeah, like, don't ask me anything yet. I haven't written the damn thing down. All right, so what goes in the little penalty box, dude? -3, I like it. So sure, you can also think about it like what makes a 0 in a way, but really the reason is we're changing the sign at the beginning, and so I don't have to do it every damn time. So -3. Then I put down what up here?
The coefficients of
Good.
the-
And am I missing anybody?
No.
No, so I can just go straight through 6, -5.
Bring it down. 6.
Yeah, so what gets things started is to bring this guy down, and then you just multiply, add. Multiply, add. If you're not careful, like I wasn't careful, these can get kind of big. Multiply, what is that, -201? Add. Cool. What's the remainder?
-198.
Good, so that's the one you're going to have to put over what you divided by. But what is this the coefficient of now?
6x.
Good, 6x squared, because it's going to go down by a degree. 6x squared minus 23x plus 67 minus 198 over x plus 3. What a shit. So a couple ways to look at this. X plus 3 times all this equals that, right? That's what it means when you divide and get an answer. Why is 10 divided by 2 5? Because 5 times 2 is 10. Cool. So this times this is this. It's actually a way you can check it if you really wanted to. Also, if it went in evenly, if this was a 0, then I would have discovered a way to factor this. Do you guys follow? So for example, if I do this one, how do I know this is going to go in evenly? Again, how do you factor the top of that? How do you factor the top of this? The x.
Yes. Yeah, because 9 times negative 4 is negative 36, and 9 minus 4 is 5, right? Is that cool? You guys are taking a little while. I was like, did I think about that right in my head? Shit. So I know it's going to go in evenly. In fact, I know the answer at the bottom is going to relate to that x minus 4. That's what it should be. So take a minute and try to set this up. Do this synthetic division, because you already kind of know what the answer should come out to be. Try to set it up correctly in synthetic division. Make sure everybody's in the right track. What goes in the little penalty box? Negative 9. I like that. And then what are your coefficients up here? 1, 5, negative 36. I like it. All right, let me catch up to you guys. So what do I put here? Yeah, whatever this is, it just comes straight down. All right, so then negative 9 times 1, negative 9. 5 minus 9, negative 4. Negative 9 times negative 4, negative 0. No remainder. And sure enough, we start with x squared, so this is going to be x. Exactly what we knew it should be. Because if I did factor this to be this, what would happen with x plus 9 and x plus 9? They would cancel. Yeah. That's chapter 7. That's chapter 7. So if it goes in evenly, that means that I could have factored the top. Sometimes it's obvious, sometimes it ain't so obvious. Okay. Let's see. What other kind of weirdness do I want to show you? Oh, so people don't realize what the remainder tells you. Like if I had 11 divided by 6, just to kind of hammer home a point, yes?
The second 36, where did it come from? I thought you were multiplying it and then...
Yep, so 1 comes out, negative 9 times 1 is negative 9. 5 minus 9 is negative 4. What's negative 9 times negative 4? 36. But no. It's always times what's down here. Yeah, negative 9 times 1 is negative 9. Negative 9 times negative 4 is 36. Yep.
Where 1 came from?
Just 1? It came from here? What's in front of the x squared? Yeah. I like it. It's that stealth 1. In fact, if I had x in there, how many stealth 1s are there? More than you know. But here's the one you know. There. First power.
Over 1.
It's over 1. Right? Shit, there's a lot of freaking stealth ones. We just decided, we just know they're there. Okay, cool. I like it. So real quick. Of course, 11 divided by 6 is going to have what remainder? You guys know? No. Okay. So 6 goes into 11. How many times? Once. This is going to have remainder 5, of course, and that remainder tells you how far away is 11 from a number that 6 could go into. And sure enough, 11 is 5 up from 6, and 6 would have went into 6. So now watch this. If I did the same thing, but I did it with this, x squared plus 5x minus 34 divided by x plus 9. Stay with me. You guys see how it's almost the same thing, except I just made that off by 2. Hopefully you guys can see. I mean, the remainder is going to be 2. But now you know what it means. So if I do this, 1, 5, negative 34. Just going to do it real quick. 1, negative 9, negative 4, 36. 2, that remainder tells me that that was 2 up from what would have gone in evenly. That's always what the remainder means. So I don't know if anybody's ever just told you that directly. Okay. Cool. All right, so that's enough with synthetic. Are you guys, if you look at that handout I give you an example in the middle. And then at the bottom, I redo the first one, the long division one. I redo it using synthetic division. So this is one we did long division up here, and then I redo it down here with synthetic division, just so you have some examples. Okay. I like it. Is there any questions on that? You guys need to see another one, or yeah?
Are we going to be able to use this way on all Disney quizzes, or no?
No, because I need to make sure you can do both.
Okay.
So I'm either going to give you a problem where the bottom is x squared plus 9, in which case you could not use synthetic division. It's got to be linear on the bottom for this to work. You'd have to use long division. Or I'm just going to give you a problem, say, use long division and then synthetic, because I want to make sure you can do both. I like that kind of problem, because then you can do it one way and you know what the answer is going to be, so you can do it the other way and know what to expect.
All right.
You can do linear for everything, right?
No, x squared plus 9. There's no way to make that linear, really. There is, but you have to use complex numbers and all this kind of shit.
Oh, okay.
So let's not do that, yeah. So if the thing I give you is not linear, if there's a square in it, a cube in it, you have to do long division. So like the very first problem from today, the x squared plus 1 was on the bottom. We have to do long division. You can't do synthetic. Why is synthetic so easy? Because it only works when the bottom is x plus or minus something. That's the only time it directly works. I like it. Now, if you go much further in math, you can get to a point where you realize you can do some adjustments and make it work for more things. Those adjustments are a little bit freaky. So we don't talk about them yet, but there are some more things you could do. So anything else about just the basic synthetic? Nothing beyond what we want to do here.
Can you do another one for the long division?
Oh, okay, sure. Is there anything special about it you want to have happen?
No, I think it's a whole, there's too many X's.
I agree. That's why they make it synthetic. So let's do one that you can't use synthetic on. Something like it. Gross. Okay, let's try this one. So let's see. What do I have to do when I do this inside here? X4.
Plus 0x to the third minus 2x.
You don't absolutely have to, but it definitely helps. And maybe you do it and you don't need it. Oh well, it's fine. All right, so help me out here.
Starts with an x squared.
Yeah, x squared times what is x4? X squared. Like, and then you distribute that to both. You get x4, that's not a surprise. And what's x squared times negative 2? Ooh, I like this. This is really gross. Then you
Switch the signs.
change the signs. So that goes away. And that goes away. So whenever that happens, you actually should bring down both of these. But does it even matter? I made this even more interesting than I meant to. How do I know I'm done, basically? Because
X squared can't go
the
back.
power here is less than the power here. So that's how I know I'm done. I can't get that to fit into there. It's the other way around. So then what can I write at the end here?
X minus 5 over x squared minus 2.
I like it. That was really weird, but, right? A few weird things. Was it too many weird things? Should I do another one that's more normal or no? Are you guys
You
okay?
don't want one?
Okay. All right, let's make one that's a little less weird here. Let's see. Let's see what happens here. So I'm not missing anything, right? So that's all right. Okay.
4x.
Yeah, so now you say x squared times what is 4x cubed? 4x. So the 4x times x squared is 4x cubed. 4x times negative 4, negative 16x. So I should put it here. Right? So then what? Change the signs. So that cancels like it's supposed to. That just comes down. 2x and 16x, 18x, and then you bring down the plus 11. So I want to show you one where there's nothing here because that's missing a term too, right? So it's going to have like gap teeth right here, right? Gap between those teeth. Right? So that comes down, this combines, you can bring that down. Now x squared goes into negative 5x squared. Negative 5. So you multiply, you get negative 5x squared. Minus 5 times minus 4 is
20.
plus 20. But then you have to change the signs. So those cancel. The 18x comes down. 11 minus 20.
Minus 19. 9.
Okay. So then I can put down here plus 18x minus 9 over.
X squared minus
Cool. I like it. Yeah.
Should we ever factor, like in the remainder there, you can pull out a greatest common factor, can't you? In that particular example.
Sure, but it's
Is
not
that
going to
like-
go anywhere.
Yeah, I know.
Yeah,
Just
yeah.
Is that the right answer? Does it not matter?
No, yeah,
Okay.
no. One thing I did this for, is everybody decent with that? That's long division, that's how it works. I can't use synthetic on this officially, right? But isn't this x plus 2x minus 2? So this is just one little peek into what you could do more with. I could synthetically divide this by 2, and then synthetically divide the remainder by negative 2. And that would effectively be doing this. Because isn't this x plus 2 and x minus 2? So if I divide by both, then I will have divided by this thing. Now, if you don't like what I just said, you're fine. You don't need to do any of that shit for this class. I'm just giving a little bit of a heads up to anybody interested. There is more flexibility to this than what I'm teaching in this class. In this class, we don't have to worry about that, but you can do more with it if you need to do it later, if anybody's going further in math. Okay, how's that? Is that decent? I love you guys. You're all like, not really, but, let me out early. No, not this early. Not at 10 o'clock. Okay, so we're going to do a little bit more. Any questions on the stuff in Appendix D? It's way at the end of the book. Okay, so let's do a little bit more, because we sort of got into this just a minute ago. And this comes up, and this is something I, sort of like when I went into that little tangent about how do you know if something divides by 4, how do you know if something divides by 2, all that kind of stuff. There's also this idea of why can you not divide by 0, or why do we call it what we do, right? So it's actually going to be a part of this section 7.1, is this idea of what that division by 0 would mean. What is division by 0? What do we normally say then? We would call this undefined, right? Why?
Divide something
Because it's
by-
freaky. Let me show you. This is kind of cool. This is a question you should ask. Don't let your teacher say because it's weird, because it's some weird shit. No, it's not good enough. Tell me why you called it undefined. There must be some reason you math people use that word, right? So stay with me now. It's going to be a little weird. What is 6 divided by 2? 3. Why? Don't tell me because 2 goes into 6 3 times. Use multiplication to tell me why 6 divided by 2 is 3, because 2 times 3 is 6. 3 is the number defined such that 2 times it is 6. So there is a number that this is defined to be. It's defined to be 3 because it does what it's supposed to do. So 6 divided by 0 would have to be the number defined such that when you multiply it by 0, you get 6. Well, if you multiply anything by 0, you get 0. So is there a number defined to do what that needs? So then we call it frickin' undefined. I mean, that's right? Because, okay, I like it. Some of you guys are like, I could live my whole life and never know that shit, Jeff. But if I'm you, I'm like, why the hell they call it undefined? What the hell? I would hope somebody's curious about why that's true. Now, hopefully everybody understands why. So let me ask you this. Let me ask you this in a little different way. I mean, that's all. If everything's numbers, great. But can somebody tell me, if I have something that looks like this, where is there an issue? Is there a value I cannot use? Well, this is a nice one to start with. What can x not be? 0. Because that would be 1 over 0 then. So what values make this undefined x equal to 0? Right? If I ask you this instead, if I ask you what is the domain of f of x equal to 1 over x? Okay, somebody's like, yeah, screw this shit. If I ask you what's the domain of this, who remembers what domain means? Hopefully. It's all the things you're allowed to beat? No.
Distribute. Not 2 lines domain and range, and you can.
Oh, okay. So you remember how you do like D and you have numbers, and R and you have numbers, and you have the little arrows?
Yeah.
Domain is all the things that can be used as inputs. Right? So it's everything that X can be, basically. And the range would be all the stuff as outputs. It's everything that Y could be. So domain is all the X's that you can use. Range is all the Y's that would come out. So this is really sort of the same question in a way, but not really. What's the domain of this? Asks you what values can I use? So the short way to say that is a lot of freaking numbers I can use. So the answer to this question is say X just can't be 0 then. All right, is that cool? So there's 2 different ways I can ask you this. And if you just always say x not equal to 0, I will understand what you mean. You're trying to say that's a value I can't use, right? So what if it looked like this instead? Why does it got to look like something else, Jeff? Well, just because it might. What if I had 4 over x plus 5? Let's say f of x equals 5. What value can I not use? What can x not equal? -5. Cool. We can all kind of see that. That's the one value that would make the bottom become 0. So then x cannot be -5. I like it. So what about this? So now you start to realize, oh, this is what he meant by if I don't know how to factor, I'm screwed. So every problem here is going to find a way to have something to do with factoring. Or factoring is going to be useful in most of the problems, or necessary in most of the problems. So this is nice because there's just one piece down here, and I can see what makes that one piece 0. This is going to have 2 pieces. I don't know what they are yet, so I better figure out what the hell they are. So how do you factor this thing? Can you factor this thing? Good. -5 and -4. So what can x not be? 5 or 4. Because either one of those will make the bottom 0. I like it. It might. So here's the idea with any question asking about domain or what values am I allowed to use. If you can say what's going to go wrong in English, you just write that in Mathish. What the shit am I talking about? Well, if I had this, 4 over 2x minus 3. What cannot happen in that? The bottom, so I'm going to say in English, the bottom can't be 0. Is that cool? That's basically period, right? Bottom can't be 0. Look at you, Jeff. Just make it all English. Can't be 0. I can't operate in full English. That's just my first language. So now you bring Mathish in. The bottom is what? The bottom is 2x minus 3. Can't be. Not equal to. 0. And then solve it. Do you guys with me a little bit? So now solve this. Add 3. Divide by 2. X cannot be 3x. I like it. We're eventually getting it to the point, let me see if you guys are able to handle this. What if I had this function? We're not talking about square roots fully yet, but you know what square roots are. You know what they cannot handle inside of them, because then it becomes complex. I don't know if everybody's talking about complex numbers. I think I asked you about that before. So what cannot happen with the end? What's got to be true? Let me say it this way. What's got to be true with the number inside? The number inside has to be what? Or 0. So the inside must be positive or 0. All right, that's English. All right, somebody figure out how to write that in Mathish.
Greater than or equal to?
Yeah, so because what's positive mean? All the numbers that are bigger than 0. So I can say the inside, x minus 2, must be positive or 0, greater than or equal to 0. And then I solve that. So the idea of, if they ask you what the domain is, you always just say the problem in English, and then you write what you just said in Mathish. People just don't believe me, but that's the bottom line. It's just true. And then you solve it. So then x has to be greater or equal to 2. Bam. If you try to plug 1 in, is it going to be okay? No. It's going to be square root of negative. It's all freaky. It's all complex. Maybe. All right. And then one last thing, and then I'll let us out of here. Oh, I'm just, you guys are spoiled. But you have to be honest with me. We kind of went through some stuff a little quickly today, but nobody wanted to stop me, so I'll keep going. Does this make a decent amount of sense here, this idea? Do you notice how, I forgot to point this out, do you notice how if I had 3x over x minus 7, what can I not use? Does the 3x matter worth anything? No, the top can be anything. What if the top were 0? Well, then the answer would be 0, right? 0 divided by almost anything is 0. Why do I say almost anything? Because 0 divided by 0 is freaky. It's another freaky thing we don't think about. So the top doesn't come into questions about domain, because the top doesn't have any restrictions. The bottom has restrictions. I like it. So when does the top come into play? If I say simplify. So remind me of this. How do I simplify this? We don't know, Jeff, until you write. All right, let me look. Sure. I threw you guys off. You're all like, wait a minute. All right, that's just numbers up there, right? Just numbers. So how do I simplify this? Yeah, divide 9 into both, so you get 4/5. I like it. Real quick, by the way, how far apart are 36 and 45? 9. So that's a good first try to see if it goes into both. And if it doesn't, then you use or like a factor of 9 to see if it goes into both. Anyway, sorry. So why does this work? Because 36 is 9 times 4, and 45 is 9 times 5. So of course those go away. Do we have to do that step? No, we sort of are able to do that in our head, right? But if I ask you to simplify this, Oh, Jeff, what you got going on, buddy? Yeah, sure. Now, here's where people do all kinds of horrific things. I mean, can you reduce, just to save yourself from yourself, can you reduce 8 over 5? Can you reduce that? Sure, but can you reduce it?
No.
That's the only thing I want to know. Even though 8 is 5 plus 3, right? You're like, that's nice, Jeff. What the hell's that got to do with your question, buddy? I'm like, I have the same question for you. If you make the mistake of just killing the x squares, you made the same mistake of somebody thinking that means shit, right? The 5s can't cancel here. Why not?
It's 5 plus 3.
Because division is not the opposite of addition. Just you guys see what I'm saying? So I can't cancel these because division can't kill parts of a subtraction problem or an addition problem. So I got to do the same thing we did here. I've got to factor them. And then I can see if there's any parts that want to die. Right? I teach very violent. Man, I watch too much Game of Thrones, man. Can't wait till that comes. Who's going to die this time? Or what body part is going to be? Okay. So how do I factor the top?
X plus 3, X minus 3.
Yeah, it's a nice one, right? X plus 3, X minus 3. That's a huge clue
X plus 3.
for the bottom, because I bet you anything it's going to be 3 times something. See if it's match up. Do you guys see that? So there's hints in these problems. So I know it's going to be XX. I know it's going to have to be 3 and 6. Did I do this? Yeah, thank God.
Minus 6 plus 3.
Yeah, minus 6 plus 3. The bigger one's negative. Right, it would be just my way to make this plus, and the whole thing goes to shit at all. And so what can cancel?
X plus 3.
Yeah, the x plus 3's go away. So your answer is x minus 3 over x minus 6. So that's the next level use of factoring, is to reduce things like this. And again, they have to be able to reduce some of them. If I can reduce some ratios of numbers, I have to be able to reduce some ratios of variable expressions because they are just numbers themselves. So for example, to do like I did earlier, just bear with me. And you're like, that's all we do, man. What if x was 5? Where'd that come from? Because x can be anything it wants to be. It's not an equation, so it could be anything. Except, of course, what could x not be?
6.
6 or negative 3. Even though those canceled, it still can't be negative 3. Because 0 divided by 0 is freaky. Right? So I picked 5, because it's not either one of those things. So what do I get on the top? If x is 5, what fraction is this? 25 minus 9? 16. And 25 minus 15 is 10, minus 18? Negative 8. Right? And then that would be what? If x is 5, yep. If x is 5, this would be 5 minus 3, 2 over 5 minus 6. And of course, 16 divided by negative 8 is negative 2. Do you guys see what I'm saying? And that would work any x you pick except the ones that would make it freak out. Pick x equals 7, pick x equals 11, pick x equal to the square root of 7. Why would you do that? I don't know, but it would still work. Okay, maybe. Okay, maybe. So that little thing in purple up here is my extra stuff that I put on top of this. Nothing you have to do yourself unless you want to. Right? So here, you guys try. Let me give you one to try here. You guys simplify this. Let's see. What you got, Jeff? I don't know, man. Oh, yeah. That's gross. It's a little too gross. Sorry. Wait. There you go. Do that. Now it's possible. So you just treat them as 2 factoring problems. The last thing you do is to see who dies between the top and the bottom. I want to get a shirt that says the GCF will save your ass. Always look for GCF, dear God. So even if you didn't see the 2 come out, it would just be a little longer problem for you. Eventually you see a 2 coming out. And the bottom, of course, is going to be little dude, big dude problem, right? Cubes. All right, let me try to catch up to you. So this guy, x minus 2, x minus 2. And then here, x cubed is xxx. 8 is 222. So one of each in the little dude. And then the other 2 of these things go here. And what's going to be in the middle? Yeah, 2x with what sign? Positive. Remember, it's much better to know why things work. That middle dude is supposed to be the cancellation dude. It's got to be the opposite sign of the first guy, so it can cancel shit that guy brings. So that's what's on the bottom now. So what cancels? Yeah, one of these x minus 2s. All right. Anything else cancel? No, because I don't have a 2 or an x minus 2 down here anymore, right? So you're basically done. You got 2 x minus 2 over x squared plus 2x plus 4. Wow. So I don't know if some of you guys can imagine the next step is going to involve what do you do with a problem like this? Cross, divide. There you go. Only time you cross multiply is if you have a fraction equals a fraction. That's the only time you cross multiply. Here, the whole idea is if it's on the top and something else on the bottom, they're going to cancel. It's going to be cross divide. So if I really want to look at this, it would be 14. This will be 14 times 2. To do it the way we would never do it, right? And this will be 9 times 3, and this will be 13 times 3, and then I can see the parts that die. Do you see why I'm doing it, though? Because that would be the way I would do it if these were all variable expressions. It would be 4 factoring problems in one problem, and then you step back and you just kill all the stuff that's on the top and the same on the bottom. It's the same thing we just did, just one more piece to it. So you just got to look across and up and over. You guys, so we're going to get into that tomorrow. Okay. I've gotten as far as I wanted to, so we can leave really early today. It's crazy. Continue to not let yourself get used to that, because there will be days you won't. Remember, the first thing we're doing tomorrow is quiz. I like it. And I just sent you out that email about the survey, so try to get that done tonight. Yeah.
What was the first step?
It's on the syllabus. I think it's the 21st. It's on the homework sheet.
Yeah.
Yeah. Okay. Whew. Yeah.
Can you run through a couple of the cube factoring?
All right.
I'm finally kind of locking down that you take the cube root of both numbers.
Yeah,
It's
yeah.
just the process of getting them.
One thing that's really good is to have a list like this.
Yeah, that would be really helpful for sure.
Yeah. So for example, like if I had 8m cubed plus 125
So then you have
y cubed. Yeah.
Okay, so then you have 2n cubed, and you have
2m, 2m, I like it.
and then you have 5y
Good.
cubed.
5y, 5y, 5y.
And then this is where I start falling apart. So I get, it would be 2n plus,
5y.
Yep.
okay, so that's the little dude that we talked about. So is that, oh, okay, so you multiply them together, so you get 4m squared.
So see how you get your 8m cubed?
Yeah, okay, so that would work there. And then you do the same to the end. Okay, so that's 125y squared.
Plus 25. So now when you do this, you get your 125
Ah, yes.
y cubed.
Yeah.
Yeah.
Then we get 10 and negative
10 my, yeah.
Okay.
Right? And what's the sign going to be?
Negative.
So for that one,
Multiply?
those two, switch the sign.
Switch the
And that
sign
gives
so
you
it can
your
cancel like it's supposed to.
Okay.
And never waste time on the big dude. You'll never factor.
Yeah, okay.
So that's why I said that's the one thing. I normally tell students don't look at any math like 10 minutes before a test because all you're going to do is freak yourself out. You're going to go, I forgot that, oh shit. But this is one thing I would say right before the test, do several of these because it just leaks out your head so quick. The process, yeah.
Where is it 10 and 1?
Oh, the middle guy is always a product of these two. One of each, two of each, product in the middle.
And then you switch sides.
Yeah, and then switch the sign Y so it can cancel shit like it's supposed to. There's also this. I'll show you guys this since you're my hardcore group of students who stayed. This is I don't like this kind of thing all that much, but let me show it to you if you like it. I don't like mnemonic devices too much because then they take you away from the idea of something. But this sign is the same.
So,
This sign is the opposite. And this sign is always positive. So what does that spell? Soap. Yeah. This is the same sign. Same sign.
yeah,
That's the opposite sign.
because you wanted to cancel.
And this one's always positive. So it doesn't screw with that.
Ah, I see.
Yeah.
Yeah, that's
So if you don't like that, that's fine with me. Because I'd rather you just know why things make sense. But then it's kind of a nice little thing to keep in the back of your brain if you want something to feel better about.
And then aside from being familiar with factoring, the best way to approach that is just know your cubes and like just
Yeah, you gotta
set,
know
you
your
can write it
cubes. You
down.
gotta know that's gonna be 5.
We're
Beyond
not-
5, I'm not gonna.
We're not doing calculators on the tests, right?
No, calculators are fine.
They're cool.
But I need to see.
The word.
Well, I don't need to see
yeah. The steps.
like. So when I say work, you know, if there was a problem where you had to do